Hello, this is the main Vodcast on air pollution. There are a few things we're not going to cover, and they'll be covered in a couple of other podcasts. For this one, we're going to describe the source of air pollutants and also the types of pollutants and their effects. We're also going to explain how the environment affects the concentration or composition of the air pollutants, and we're going to explain how we can control air pollution. First, what makes the air polluted? Well, air is polluted when chemicals in the atmosphere are in concentrations that are high enough to harm organisms, ecosystems, or human-made materials. And that is the definition of air pollution. The source can come from natural or anthropogenic sources. With natural, it's sort of unusual because for something to be polluted, generally it has to be from anthropogenic or man-made sources, but in this case it also can come from natural sources. Example of natural sources can be from volcanic eruptions. It can also be from forest fires, and there can be VOCs or volatile organic chemicals that are released by some plants. And by the way, VOCs can also come from anthropogenic sources too, as we'll see later in the podcast. Approximately 147 million metric tons of air pollution are released annually into the atmosphere in the United States by human activities. Worldwide, it is 2 billion tons. And developed countries have been improving air quality. In the developing world, the air quality has been getting worse. Air pollutants can be put into two categories: primary pollutants and secondary pollutants. Basic difference between the two is that primary pollutants are harmful chemicals that are directly emitted into the air, and secondary pollutants are also harmful chemicals, but they come from primary pollutants that have reacted either with each other or with basic components of the air to form this new pollutant, which is a secondary pollutant. And actually, frequently it's not just a basic component of the air; it frequently can be sunlight. Examples of the primary pollutants would be particulates, which are just simply particles, very, very small particles that are in the air. For example, soot, say from burning coal. Hydrocarbons, carbon monoxide, nitrogen oxides, or NOx. X could stand for different amounts of oxygen, like NO2 or NO3. Sulfur dioxides, same thing with the X there, could stand for different numbers. And volatile organic compounds, or VOCs. And a lot of these come from burning fossil fuels and also from waste. Examples of a lot of secondary pollutants would be ozone, or O3. Now, ozone is very unusual in that ground level ozone is a pollutant, while stratospheric ozone is actually very good for us. It protects us from ultraviolet radiation, as we will see in another vodcast in this unit. And PAN, or PAN, acids, or sulfuric and nitric acids, which are primary components in acid precipitation or acid deposition, and we're going to learn about that in another vodcast. Ozone and PAN form when NOx, CO, or VOC react with sunlight, and we'll see a little bit later that they are the chief components of smog. This table on this screen and also the next screen, which continues the table, these show the primary air pollutants, and they also show where they come from. They describe them and give the effects, and you do need to know most of these. Some of the more important ones, we're going to go into some detail about them, but you do need to know this table. And here's the rest of it. There's ozone and PAN, and you see what PAN stands for. These are the sources of primary pollutants, where they come from. Like, for example, sulfur dioxide. Most of it comes from fuel combustion, the rest from transportation and industrial processes. On the other hand, when you look at nitrogen oxides, well, a lot comes from fuel combustion, more of it is from transportation. The main difference from that is that sulfur dioxide primarily comes from burning coal, and coal is mostly used in power plants, and nitrogen oxide comes from burning gasoline, and that's used more in terms of motor vehicles. You got VOCs, and then there's the particulate matter and carbon monoxide. Now here's particulates, and for a scale here, you see human hair and also fine beach sand. 62% of particulates come from natural sources, 38% from human sources. Examples of this would be coal-burning power plants and industrial plants, also motor vehicles, plowed fields, road construction, and tobacco smoke. The finer it is, the more harmful it is, because the deeper it can get into the lungs. PM10 has an average diameter of less than 2.5 micrometers, and that's classified as fine. And the ultrafine particulates are PM2.5, and that has an average diameter of less than 2.5 micrometers. The symptoms of people who are suffering from this is that it irritates the nose and the throat, it can aggravate asthma and bronchitis, and overall it can shorten someone's life. There are two types of smog. There's industrial smog. Industrial smog is mostly particulates from mainly burning coal, and it includes particulates, SO2 and H2SO4, which is sulfuric acid. It's a problem in developing countries like China today, and it has been a problem in the past in the United States and in London. When you heard of London fog, that was this industrial smog, and it is responsible for killing many, many people. And today it's not a problem in developed countries because we remove a lot of the particulates, we allow sulfur out of the emissions. We're going to go a little bit into that in this vodcast, and also in the acid precipitation vodcast. And also we're going to go into it a lot in the future unit on conventional energy. What's more of a problem in developed countries is photochemical smog. This is a mixture of primary and secondary pollutants that form in the presence of ultraviolet radiation, which is a part of sunlight. Nitrogen oxide, which is one of the things that give smog its brown color, and ozone and pan are the main components of the smog. These are common in cities with sunny, warm, dry climates and have many motor vehicles. Examples would be Los Angeles, Mexico City, and Sydney, Australia. Temperature inversions can make this worse, particularly in places like Los Angeles. This occurs when a city is in a valley or a basin which restricts air motion. First, the skies are clear at night, and the ground and the surface air, the air which is close to the ground, cools very quickly, and the air above it remains warm. So this is the opposite. Normally, as you go up, it gets cooler. What's happening now is as you go up, it gets warmer. And then during the day, the sunlight creates the secondary pollutants, and that warm layer then traps that cool air. And that's trapped, and because it's trapping that, it's also trapping the secondary pollutants. And then the mountains around the city basically prevent those from blowing away. Then you end up with the smog, because none of the pollutants can get away. On the other hand, air pollution can also travel quite a bit. You see here on the map how air pollution can travel, and it's actually quite a bit more extensive than this map can show. Dust storms in the Sahara have been shown to reach the Amazon basin and actually fertilize the Amazon, which is a good thing. But on the other hand, the air pollution that's being caused in China from the industrial plants and the coal burning power plants have actually been measured on the US West Coast. Indoor air pollution is a major problem. It's actually a greater threat than outdoor air pollution, and it is the world's most serious air pollution problem for the poor. One reason for that being for the poor is because they tend to have coal burning stoves, and coal, as you know, is a very serious pollutant. They have poor ventilation in their homes, and homes tend to trap the pollutants because frequently there's poor ventilation. So the levels of pollutants tend to be quite a bit higher. The levels for 11 common pollutants are 2 to 5 times higher than outdoors. Another problem too is that particularly in the United States, most people spend 70 to 98% of their time indoors or in vehicles. This diagram here shows you many sources for indoor air pollutants. Sick building syndrome is also a big problem. Almost 1 in 5 commercial buildings in the United States is considered to be sick. To be sick, at least 20% of people working in the building would have to show the symptoms of sick building syndrome in the building, and usually it gets relieved when they leave the building, or they find very high levels of indoor air pollutants in the building. Generally, sick building syndrome is caused by either poor ventilation or by contaminants. For example, mold is a very common contaminant. Symptoms include headache, dizziness, irritation of the eye or the nose or the throat, and nausea. Usually these symptoms clear when someone leaves the building or the room which has this. The solution to this is usually either remove the pollutant or to improve ventilation. Here are the 4 most dangerous indoor air pollutants. Tobacco smoke, and I don't think I need to go into that. Formaldehyde, and formaldehyde is a colorless chemical, and it's very irritating. It affects 20 to 40 million Americans. The symptoms include chronic breathing problems, dizziness, a rash, headaches, irritation to the nose, eye, and throat. It increases the chance of getting Lou Gehrig's disease, also called ALS, and that is a progressive nervous system disorder which doesn't affect the brain, but you gradually lose control of your limbs, and eventually it kills you. And also it increases the chances of cancer. Formaldehyde is found in building materials, in furniture, drapes, the adhesive for carpeting and wallpaper, and also in fingernail hardener. Radon gas, and radon is a colorless, odorless radioactive gas. It's produced by the natural decay of uranium-238. It seeps from the soil into buildings through cracks in the foundation or openings around the pipes or open windows, or any way that gas can go from the soil into the building. And it increases the chances of lung cancer. What I recommend is before you buy a house, make sure that the engineer who inspects the house does a test for radon. If it's high in radon, then don't buy the house, or make sure that something is done to make sure that there isn't a problem with radon. And remedies for radon include sealing the cracks that the radon can go through, and also by increasing ventilation. And the fourth most dangerous indoor air pollutant are very small particles. Now we come to the last part of the Vodcast, which is reducing air pollution. Legislation is one of the main ways of reducing air pollution, and the Clean Air Act, which was passed and modified in 1970, 1977, and 1990, is a main thing. What it did is establish national air quality standards for 6 pollutants, and you'll find the pollutants in the table here. Averaging time is the period over which the concentrations are measured and then averaged. You only see one standard. There are 2 standards they have. One standard is primary standard, and that's to protect human health. Secondary standard is for protecting environmental and property damage. And then there's the TRI law, or Emergency Planning and Community Right to Know Act of 1986. This was in response to the Bhopal, India disaster, which was the worst industrial disaster in the world. And we went over this in an earlier unit. And briefly, a Union Carbide industrial chemical plant had an accident, and a toxic cloud was released. It killed thousands and disabled thousands more. At the same time, a similar disaster, but not as bad, happened in West Virginia. In response to this, this act was passed, and the EPA has established national emission standards for 188 hazardous air pollutants. Also, it goes into pollutants that are not that pollute the air, but also pollute the water. This mandates that companies release to the public Toxic Release Inventory Report, and that's the TRI report. It reports annually how much each chemical is released to the environment and are managed through recycling, energy recovery, and treatment. And each company has to release this. Since first TRI report in 1988, the reported emissions have greatly dropped. Now, there are some problems with the laws, even though the laws have greatly reduced emissions. They rely on cleanup instead of prevention. And the U.S. is far behind fuel efficiency standards for cars, SUVs, trucks, compared to the European Union, Japan, and China. Emissions from motorcycles, lawnmowers, leaf blowers, chainsaws, and other things which use small engines are inadequate. For example, a 1-hour ride in a motorboat emits more pollution than a car emits in 1 year. There's almost no regulation for ocean-going ships that are in U.S. ports. Airports are exempt from most regulations. Greenhouse gases are unregulated. Congress, for one thing, considers CO2 not to be a pollutant. Ultrafine particles are unregulated. Also, urban ozone is too high in some areas. Also, the laws have not really solved indoor air pollution, so the indoor air pollution laws need to be fixed. And also, the enforcement of the Clean Air Act is relaxed. The funding to states is less than it should be, and the federal standards have dropped. Now, other types of ways of reducing pollution. When it comes to stationary air pollution, in particular for power plants. When it comes to preventing it, you can switch to energy sources that pollute less. Like for power plants, burn natural gas instead of coal. Use wind power, use solar power, burn low sulfur coal, remove sulfur from coal, convert coal to a liquid or gas. These things we're going to go into much more detail later in the year. Dispersion or cleanup of the air pollutants. Using tall smokestacks will put the pollution above the inversion layer. So when there is an inversion, which, remember, traps the pollutants causing smog, that will put it above it so it won't get trapped. Also, removing the pollutants. A catalytic converter is an example of this. What a catalytic converter does is, a catalyst is like an enzyme. What it will do is it will convert NOx into N2 and O2, which are not pollutants. Pollutants can be taxed, which isn't being done. The result of these things, and also from the Clean Air Act and TRI laws, between 1980 and 2006, sulfur dioxide emissions decreased 66%, NOx decreased 41%, PM10 decreased by 28%. For motor vehicle air pollution, with prevention, you can use mass transit, you can walk, bike, or carpool. You can also have HOV lanes, which you can see, like for example, on the LIE, where during commuting times, only people who are carpooling or have hybrid cars are able to use those lanes. Use less polluting fuels. For example, there are actually cars which don't pollute at all. Like there are some cars that use compressed gas. There are cars which are completely electric. You plug it in. And in a sense, they do pollute, but the pollution would be at the power plant, not at the car. And that's actually less polluting than from the car itself. It's also a lot cheaper too. You can improve fuel efficiency. Cars today are actually much more fuel efficient than they have been in the past. Hybrids is another way for improving fuel efficiency. Also, smaller cars are more efficient than larger cars. And get the older polluting cars off the road, and also have a tax rebate for fuel efficient vehicles. And then there's cleaning up the air pollution. You can require emission control devices. A catalytic converter is one way of doing it. It's in basically all cars today. It's the same thing that we discussed before. Inspect car exhaust systems regularly. This is done annually in New York, and some people say it should be done twice a year. And also set strict emission standards. And as a result of this, today's cars emit 75% less pollution than pre-1970 cars. Oh, and also pre-1970 cars, there was lead in the gasoline, so there was lead that came out in the pollution. And lead is a serious air pollutant. And if you look over here, lead can accumulate in the body and lead to brain damage and to death. Indoor air pollution. Some ways to prevent it is ban smoking or limit it to well-ventilated areas. Have stricter formaldehyde standards. Use less polluting substitutes. Use office machines in well-ventilated areas. Like coffee machines, for example, they release ozone, and ozone is an irritant. Install carbon monoxide detectors. Also, removing shoes before you enter your home. Shoes will track in things like pesticides and pollen. Cleanup or dilution of air pollutants. Use adjustable air vents for your workspaces. Increase intake of outside air and change air more frequently. Use efficient venting systems for wood-burning stoves, and also use exhaust hoods for stoves and appliances that are burning natural gas. Now we come to our concluding questions. Number 1, what is the difference between a primary and secondary pollutant? Number 2, what causes photochemical smog? Number 3, how did the Clean Air Act reduce pollutant levels? And number 4, how can indoor air pollution be prevented? That concludes this podcast, and I will see you in class tomorrow.